Welcome to the Final Competition CAD Files screencast. In this competition, I'm going to show you how to access the CAD files that are already created for some of the components that you get in the final competition. I'm going to tell you a few things about how those components work, or at least how the CAD files for those things work, and then also where to store those. So first off, let's go to the V drive. So new folder, go to Building Shares or V drive, LHS for Lindbergh High School, Classes, Robotics. Most of you should have access to this folder. It's possible that there's a couple of the newer students that don't have access yet. Click on the 2016-2017 year. And we've got folders for the things that we've already done so far this year. The two new folders are the Final Competition Kit of Parts CAD files and the Final Competition Team folders. We're going to start in the Final Competition Team folders. I'll open that. I have folders created for each of the teams. This is where I recommend that you store your CAD files. You might also back up your CAD files in your own W drive so they don't get deleted or lost or changed. But this is a good place for you to put them so that you can work together. Okay, I'm going to open one that's called an example folder. I'm going to leave it over here. I'm going to open a new window, right-click on Windows Explorer, go to the same place, V drive, LHS, Classes, Robotics, this year. And then the first thing I'm going to do is go into the CAD files, or the Kit of Part CAD files, and I'm going to take these CAD files and I'm going to copy and paste them into my folder. And the reason for doing that is that you'll have them stored locally on your own folder, and when you have SOLIDWORKS access these files, you want to have them access them from the same folder as all of your other CAD files. That way also, if another student happens to rename one of these things, for example, or if I later make changes to these or they get lost or deleted, you'll still have access to them. So I'm going to select all of them, right-click, copy, go into this folder, right-click, paste, and good. Now they're all in my folder called example folder. Okay, I'd like to spend a few minutes going through and just showing you what these all look like, and also telling you a few specific things about each of the components. So here we go. I'm going to close this. I'm going to start with the first one, the 10-tooth pulley. Now, one thing you're going to notice when you open it up in SOLIDWORKS, it's going to ask you to proceed with feature recognition. I'm going to tell you that you should say no to this. You can, if you would like, but the purpose of doing feature recognition is when I downloaded this file from the company that I bought the pulleys from, it was downloaded as an STEP file, which is a generic CAD file that can be opened by almost any CAD software. And it's literally a bunch of points, a whole bunch of points in three-dimensional space. And in order for SOLIDWORKS or any CAD program to just view it, they can just view those points as one object. But if we proceed with feature recognition, it will break this part up into cylinders and squares and rectangles and things like that. And it'll basically figure out the series of steps that it would have had to do in order to make this part. And if you do feature recognition, that allows you to make changes to the part. In this case, these are components that are given to you just as they are, and you really should not be making any changes. Might be a couple exceptions to that, but for the most part, I would say no, don't proceed with feature recognition. So there we go. So this is the pulley that you're given. It has a 1/4-inch diameter hole, and it's meant for a belt to go around it. I think that's all I need to say about that. Okay, next on our list, the 10-tooth sprocket. Again, no with feature recognition. That's what the 10-tooth sprocket looks like. That's the smaller sprocket that you're given. Let's actually close these out after I do each one of them. Next, the 20-tooth pulley. It's going to look the same as the 10-tooth pulley. 24-tooth gear. Now this one you're going to know, so no feature recognition. You're going to notice does not actually look like a gear, right? A gear should have teeth that are going up and down and up and down. This is kind of like what we did for the Sumo Bot. What's shown, or the cylinder, the bigger cylinder that's shown is what's called the pitch diameter, or at least the diameter of that cylinder is called the pitch diameter. And if you look at it from the side, the way I modified this gear that I downloaded from the company, but I modified it to just be a circle. If it did have teeth, the teeth would go up above this pitch diameter, down below the pitch diameter, up above it, down below, up above it, down below. If you imagine having another gear that you want to mesh with this, in order to have those teeth mesh with each other, you'd have the two pitch diameters touching. And so basically when you're setting up a gear system, if you are using gears in your robot, you can mate this gear to another gear just by having the two faces of those cylinders touch, and that should make the gears line up. Okay, that's the 24-tooth gear. 24-tooth sprocket you can open and take a look at. The last thing I want to mention is the second to last thing, the 56-tooth gear with 1/4-inch bore. If you open that up, this is the biggest gear that you're given. And the 1/4-inch bore, what that means is that the hole in the middle has a diameter of 1/4 inch. And actually the gears, the largest gears, actually don't have that size hole. They actually come with a 0.3125, which I believe is 5/16. This is the actual size hole that they come with, but there is a nylon spacer that I can give you. It's called a bushing, that you can place in the inside of this hole to make the hole actually have a diameter of 1/4 inch. So the reason that I have both of those listed in your folder is that you can choose to have the gear have a 0.3125 5/16 inch bore if you'd like, but you can also change it by putting that nylon spacer or bushing in to make it a 1/4 inch hole. All of the rest of the pulleys and gears and sprockets, all of them have a 1/4 inch bore. This is the only one that has a larger bore. Okay, you also need the motor. Let's open that up. Here's what it looks like. It's not gold in real life, but that's the color that one of my former students who drew this up decided to make it. One thing I want to mention, this is actually a motor. That's the motor part, and a gearbox. This motor itself is a lot like our SumoBot motors. However, it's bigger and it has more power. And this gearbox gears down the motor quite a bit. So it makes the output shaft go a lot slower than the original motor shaft. You'll notice just when you're designing things in CAD, this is pretty big. I think if we just look at the dimensions of the motor itself, let's say we measure from there to there. It's about, what I'm looking at is the dy in the y direction, 2.9 inches, so about 3 inches, and that's not even including the motor shaft that's sticking out. The motor shaft itself, the diameter of that shaft is 1/4 inch. That will fit in all of the different gears that you're given, with the exception of the biggest gear. It'll fit in all of those. Something else to notice that that may be important for your designs is if you look at the gearbox itself and look at the output shaft is not in the middle. So depending on how you arrange this motor on your robot, you might arrange it so that the output shaft is lower. You might also imagine mounting it on your robot so the output shaft is higher, or so that the output shaft is on the right-hand side or left-hand side, for example. Okay, those are the main things that I wanted to tell you about the kit of parts and the gears that are given to you. Good luck.